Hello there, welcome to the June 2019 Core Paper 1. Here we're looking at question 7. The line L has equation of this thing here. Now first of all I'm going to write line L1 in my preferred vector form. So that's going to be 1 minus 1, 4 plus lambda lots of 2 minus 1, 3. And L2, I'm going to write that in my preferred vector form as well. That's going to be 1, 0, 3 plus t lots of 1, minus 1, 2. Where t is a scalar parameter, show that L1 and L2 lie in the same plane. Now for two lines to lie in the same plane, effectively one line would be along that part of the plane, one part of the the other line would be that part of the plane, and at some point they would intersect. So you could just define your plane by the two direction vectors, making sure that they do intersect at one point. If they don't intersect at a point, then they can't form a flat sheet, a flat piece of paper kind of plane. So all we need to do really for this question is just show that they do intersect. So let's call the top one, let's refer to it now as 1 plus 2 lambda. The second one would be minus 1 minus lambda, and the bottom one would be 4 plus 3 lambda. And on the bottom one it's going to be 1 plus t, minus t, and 3 plus 2t. So for both the x parts of these vectors here, I'm going to set them equal to each other. 1 plus 2 lambda equals 1 plus t. Cancel out the 1's on both sides and you'll get t equals 2 lambda, that's quite helpful. And on the y equation on both of them, I'm going to get minus 1 minus lambda equals minus t. So now if I solve these two simultaneously, I'm going to get minus 1 minus lambda equals, t is equal to 2 lambda, so it's minus 2 lambda. Add the 2 lambda onto the other side, add the 1 onto the right hand side, I'm going to get 1 equals lambda. So therefore 1 equals lambda, so therefore t equals 2. So this is my solution. Let's just now check the z component of this when we plug in lambda equals 1 and t equals 2. So that's going to be 4 plus 3 lambda equals 3 plus 2t. So when lambda is equal to 1, we're going to get 4 plus 3, which is 7. And hopefully on the right hand side it will equal 7 as well. So that's going to be on the right, on the L2, 3 plus 2t, 3 plus 2 times 2, so that would be 3 plus 4, which is 7 as well. Lovely. So the z component's equal, so therefore we could find the coordinate of intersection. Coordinate of intersection equals, so let's plug lambda equals 1 into the top equation. It doesn't matter which one you plug it into. It's going to be 3 minus 2, 7. So that's going to be the coordinate of intersection, and then we just need to write a concluding part to say as the two lines intersect, they form a plane. As the two lines intersect, they form a plane. They can form a plane. Okay, so there we are. That's the answer for this part here. 3 minus 2, 7 is our intersecting coordinate. Part B is write down a vector equation for the plane containing L1 and L2. Well, that would be a good idea might be to use our intersecting coordinate, but any coordinate would be fine. You could use the starting coordinate for L1, the starting coordinate for L2, 3 minus 2, 7, the intersecting coordinate. Whichever coordinate you choose to use, it just needs to be a coordinate on the plane. Then it's going to contain both of the direction vectors, so 2, minus 1, 3, and t lots of 1, minus 1, 2. So there we are, that's the answer for part B. So part C wants us to find to the nearest degree the acute angle between L1 and L2. This is a pretty standard use of the dot product rule here. So we've got one line here, one line here. To work out the angle between the two vectors, we need to just use the dot product of 1 minus 1, 2, and 2 minus 1, 3. So let's go ahead and do it then. The dot product rule, just a reminder, is A dot B equals mod A mod B cos theta, where we have to label one of these vectors A, one of these vectors B. So it's going to be 2 minus 1, 3, dotted with 1 minus 1, 2, equals the modulus of vector A. That'll be 2 squared is 4, plus 1 squared is 1. Doesn't really matter about the minus because you're going to square it anyway, plus 3 squared, times the square root of 1 squared plus 1 squared plus 2 squared, cos theta. So the dot product, you do the dot product by multiplying the x's together, the y's together, and the z's together. The x's together are the top bits, that's 2, 1 minus 1 times minus 1 is 1, and 3 times 2 is 6. Then we're going to divide these two square roots onto the other side, so that's going to be 4 plus 1 is 5, plus 9 is 14, times 1 squared plus 1 squared plus 2 squared, that's 6, equals cos theta. So therefore theta is going to equal cos inverse of 9 over the square root of 14 times the square root of 6. And I'll just grab my calculator for that bit there, so make sure you're in degrees mode for this calculation here. Cos inverse fraction button 9 over square root of 14 times the square root of 6, and close your brackets, and you get 10 point, what is it, to the nearest degree? Well, that's 11 degrees then. 10.89 was the answer there. 11 degrees, so that's the final answer to the nearest acute angle, the nearest degree. So there we are, that's the answer for question 7 there, worth 7 marks in total. Not a bad vectors question, to be fair. Let's now move on to the final question of the paper, question 8.